Hi guys, here we go with week 2 of this e-learning. First, we are going to go over all of your vocabulary words for the story. The first word is calculation, which means when you find a calculation, you do math to find an answer. An example of this is Mina did a quick calculation to figure out if she had enough money for 6 tickets. Second word, sorry about that guys, is orbit. Orbit, an object that orbits something, circles around it again and again. An example, it takes a year for the Earth to orbit the Sun and a month for the Moon to orbit the Earth. Third word, spheres. Oh no. You guys know this program and I don't get along. All right, spheres. A sphere is anything that is shaped like a ball or globe, as my kids are laughing at me. Basketballs, soccer balls, and baseballs are all spheres, but footballs are not. Next word, criteria. Criteria are rules for judging something or making a decision. Blood pressure is one of the criteria doctors use for evaluating your health. Approximately. If two things are approximately the same size, they are nearly or about the same size. The recipe called for approximately 2 cups of oil, so I did not measure exactly. Diameter. You can measure across the center of a circle to find its diameter. The large pizza pan has a diameter of 14 inches. Astronomical. The space exhibit included amazing astronomical instruments to study stars. The space exhibit included amazing astronomical instruments to study stars. How about I go back and read the definition? Something astronomical relates to outer space or astronomy. Evaluate. When you evaluate something, you examine it closely to decide its value. Reading food labels can help you evaluate the nutritional value. And we are back to the beginning. You can find those words on StudyMate. If you go to the assignments tab on Canvas, there is a link for you so that you can play some of those StudyMate games for your test on Friday. Our story this week, if you want to follow along with me, is on page 346 of your hardback book. It's called When is a Planet Not a Planet? You can come back and listen to the story whenever you want throughout the week to help you answer the questions. You can use your book to answer the questions. I would reread it on your own a time or two just so that you are very familiar with it. All right, follow along. Here we go. My very eager mother just serves us 9 pizzas. A silly sentence, yet school children have memorized it for years because it helps them memorize the planets in our solar system. The first letter of every word stands for a planet, in the order of how close it is to the sun. My very eager mother just served us 9 pizzas. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Mercury is the planet closest to the sun, and tiny Pluto is the farthest away. This is until recently. Pluto is still there, of course, along with the planets, asteroids, comets, and meteors, and bits of space rock and ice. Pluto is part of our solar system. Pluto and all other objects orbit or travel around the sun. My very eager mother just served us 9 pizzas is a composite of photos taken on many different NASA missions. It illustrates our solar system. Our star, the sun, is at the far left. Pluto is at the far right. So if you're looking at this picture right here, the wispy tail of a comet is shown in the lower left, and the southern ring nebula is near the lower right. The other faint objects in the image are artistic additions created with a computer. However, on August 24th, 2006, the International Astronomical Union, the IAU, a group of individual astronomers and astronomical societies from around the world, made an announcement. They declared that Pluto was not a planet. Suddenly, my very eager mother just served us 9 pizzas didn't work anymore, because now there are only 8 major planets orbiting the sun. Perhaps someone will create a new sentence to help us remember their names in order. Names are important, but they are not the only things to know about the planets. Learning how planets form, where they are located, and what they are like is the kind of activity that makes science exciting and fun. Pluto's problems. There are 2 groups of planets in our solar system. The planets closest to the sun, Mercury, Venus, Earth, and Mars, have a solid surface made of a mix of rocks, dirt, and minerals. The planets farthest away from the sun, Jupiter, Saturn, Uranus, and Neptune, don't have a solid surface. They are made up mostly of gas with a rocky core. Scientists have a theory about why some planets are terrestrial or made up of rocks and dirt, and why some are composed primarily of gas. Most scientists believe that our solar system began as a space cloud called a nebula. The nebula was made up of bits of space dust, rocks, ice, and gas. A tiny star, not yet ready to give light, began to form in the center of the nebula. The star was our sun. As years passed, the sun grew big enough that high temperatures and extreme pressure caused hydrogen at the center of the sun to begin to fuse into helium and release energy as well. Release energy as light or sunshine. Meanwhile, the nebula continued to orbit the new sun until it formed a large flat ring around it. Scientists call this ring a protoplanetary disk. The disk or ring was hottest where it was closest to the sun and coolest at its outer edge. As the disk swirled around the sun's gravity went to work. It pulled and tugged at the bits of rock, dust, ice, and gas until they came together in clumps of material we now call planets. A small portion of the Orion Nebula, which is 1,500 light years away from Earth, at least 153 stars forming new solar systems. Scientists believe our solar system formed in just this way. The planets that were closest to the sun didn't keep much of their gas. The sun's heat blasted it away, leaving behind solid spheres of matter and with only a little gas. Those spheres became the terrestrial planets, Mercury, Venus, Earth, and Mars. But on the outer edge of the disk, far away from the sun's heat, it was much cooler. The clumps of rock and dirt there still had their thick layers of gas. They didn't burn away. The planets farthest from the sun became the gas giants, Jupiter, Saturn, Uranus, and Neptune. Because astronomers still believed this theory about how our planets formed, they had a problem with Pluto. When it was first discovered in 1930, astronomers assumed Pluto was made of ice and gas because of its great distance from the sun. However, by 1987, Pluto had moved to a position, that only occurred twice in its 248-year orbit, and scientific instruments had improved. Astronomers were able to study Pluto in the light that reflected off of it. Their instruments told them that Pluto was dense and must have a rocky core. That new information raised questions. If the planets closest to the sun were rocky, and the planets farthest away from the sun were mostly made of gas, why was Pluto, the most distant planet of all, made of rock? There were other questions as well. Pluto's orbit is different from the orbits of the planets. Think of an orbit as a lane on a racetrack. Just as runners have their own lanes on the track, each planet has its own orbit around the sun. For runners, all the lanes together make up the racetrack. For the planets, all their orbits taken together make up the orbital plane. Just as runners don't run outside their individual lanes, planets don't travel around the sun outside their individual orbits, except for Pluto. Pluto crosses Neptune's orbit. All of the planets, comets, and asteroids in the solar system are in orbit around the sun. Their orbits line up with each other, creating an imaginary flat disk called the orbital plane. Pluto's orbit, which takes 248 Earth years to complete, brings it outside the orbital plane for 20 years of each orbit. Pluto moves inside the orbit of Neptune, making Neptune farther from the sun than Pluto. Pluto was inside Neptune's orbit from 1979 to 1999. The shape of Pluto's orbit is different too. The larger planets travel around the sun in an oval-shaped orbit. Pluto's orbit is more of a stretched-out oblong. The other planets' orbits are level with the sun. Pluto is tilted. Comets' orbits are often tilted, so astronomers wondered, could Pluto be a comet? And of course, there is Pluto's size. Astronomers knew Pluto was tiny when it was discovered in 1930, but because it was so far away, it was hard to see the planet clearly. Pluto appeared as a tiny dot of light in the night sky. Then telescopes improved. In 1976, American astronomer James Christie discovered that the tiny dot everyone thought was Pluto was really two objects. Pluto had a moon, Charon. Once astronomers discovered that Charon was separate from Pluto, they realized that Pluto was even smaller than they had originally thought. Pluto is only 1,440 miles in diameter. They began to ask, is Pluto too small to be a planet? And since they had found Charon, they wondered, were there more objects out there the size of Pluto? Were they planets too? Finding planets. In 1992, astronomers made an amazing discovery. 9.3 billion miles away from our sun is another region of space. Shaped like a disk, astronomers believe it contains approximately 70,000 icy objects, including Pluto. This area of space was named the Kuiper Belt, after the Dutch-American astronomer Gerald Kuiper, who lived from 1905 to 1973. In 1951, more than 40 years before its discovery, Kuiper actually predicted that a region like this might exist. Michael Brown, Chad Trujillo, and David Rabinowitz are planetary astronomers who study Kuiper Belt objects, or KBOs. People often call these men the planet finders. Together, they hunt for planets at the outer edge of our solar system using the Samuel Oschin telescope or at the Palomar Observatory in California. The Oschin telescope is a wide-field telescope, which means it views broad regions of the sky at once. When paired with a camera at the observatory, it can take pictures of these large areas. In the past, astronomers had to spend their evenings peering through telescopes in order to study the night sky. Now, things have changed. Robots control the Oschin telescope and its camera. In the evenings, the cameras in the telescope at the Palomar Observatory are at work. They take 3 photographs over 3 hours of the part of the night sky the men want to study. An object moving across the background of billions of stars and galaxies will be captured in pictures. The pictures are then sent from the telescope's cameras to a bank of 10 computers. At the California Institute of Technology, next the computers decide which object appears to be moving and therefore might be a planet. Usually the computers select about 100 objects. When the men arrive at work each morning, the pictures are ready for them to view. Mike Brown says many of the objects he looks at on his computer screen are not planets. Many are caused by some kind of flaw in the telescope's camera, but every once in a while, an astronomer will get very lucky and something new and exciting will appear. That's how Mike and his teammate discovered 2003 UB313, or Xena, as it was nicknamed, on October 21st, 2003. Mike says, "The first time I saw Xena on my screen, I thought there was something wrong. It was too big and too bright. Then I did a calculation of how big it was and how far away it was. Xena is the most popular object ever seen in the orbit around the sun. Pluto is 3.6 billion miles away, but Xena is 10 billion miles away and is approximately 400 miles bigger in diameter than Pluto. It takes Xena more than twice as long as Pluto to orbit the sun." Xena was also a nickname. On September 13, 2006, the newly discovered celestial body officially became Eris, for the Greek goddess of strife and discord. It seems an appropriate name since there was a lot of strife and discord around Eris. Was it a planet or not? What is a planet? Because scientists always check and recheck their work, Mike Brown and his team of astronomers didn't announce their discovery of Eris until January 5, 2005, after they had had a chance to verify their information. When they revealed their discovery, many people thought the solar system had gained its 10th planet, but others disagreed. Soon an argument was raging among astronomers all over the world, and the argument came down to one question: what exactly is a planet? It seems surprising, but until August 24, 2006, scientists had never had a definition for the word planet. Dictionaries had definitions, of course, but most said something similar to a large celestial body that circles around the sun or another star. For a scientist, that definition had problems. For one thing, what is meant by large body? Jupiter, the largest planet in our solar system, is 88,700 miles in diameter, and it is a planet. Pluto is only 1,440 miles in diameter, and at the time, it was a planet too. The question, what is a planet, needed an answer, and an international astronomical union decided to create not one definition, but two. The IAU came up with 3 classes of objects that orbit the sun. Planets, dwarf planets, and small solar system bodies. The IAU decided that a celestial body is a planet if it orbits the sun, is round and nearly round because its gravity has pulled it into that shape, is big enough that enough gravity to clear the neighborhood around the orbit. The first 2 qualifications for planethood orbiting the sun in a round shape are easy to understand. The concept of clearing the neighborhood is a little more difficult. It might help to think of planets as the schoolyard bullies of the solar system. In order to clear the neighborhood, a planet has to be big enough and have enough gravity to get rid of any celestial objects in its way. A large planet might clear its orbit by using its gravity to pull other smaller objects toward it and destroy them, the way asteroids are destroyed when they hit the Earth. A planet might clear its orbit by attracting small objects toward it, then turning them into moons that remain in orbit around the planet. Sometimes a planet will simply push a smaller body into a completely different orbit and get rid of it that way. But no matter how it does this clearing, according to the IAU definition, a planet must travel in its orbit itself. The secondary category of planets, called dwarf planets, have the following characteristics. They must orbit the sun, they must be round, not be a moon or satellite or another planet. By this definition, Pluto is a dwarf planet, and although Charon is formally a moon, is still locked in an orbit with Pluto, it is a dwarf planet too. Now they are known as a double planet system. Ceres is a dwarf planet also, and Mike Brown's discovery, Eris, is one as well. They are dwarf planets because they orbit the sun. They are round and they are not moons of another planet, but they're too small to have enough gravity to clear their neighborhood. Pluto, Charon, Ceres, and Eris are all KBOs, orbiting far out in space with other objects in Kuiper's belt. Everything else, asteroids, comets, meteors are now members of the third class of objects that orbit the sun and are called small solar system bodies. Some astronomers think the definition of a planet will change again in the future. Others think the current definition is a good one and will last. Science is exciting because it continually changes as new information is discovered. A long time ago, we thought there were 6 planets, then we thought there were 8. For a while there were 9, then it was back to 8. Then with Pluto, the number jumped to 9 again, and now it's back to 8. And that is just in our solar system. We know our sun is not the only star that has planets to orbit it. New planets are forming around new stars, making our solar systems. There are 200 billion stars in the Milky Way galaxy alone, and there are billions of galaxies full of stars in the universe. As we study those planets and the stars they orbit, we ask questions. Are there other planets like Earth? Somewhere in the universe, does life exist on them? We ask questions as we study the planets in our solar system too. Does life exist on one of them, or even one of the moons? Did life ever exist on any of them? Is Earth the only planet with life? Are we alone in the universe? In January 2006, NASA launched the New Horizons mission to Pluto. The spacecraft reached Pluto and Charon during the summer of 2015 and began sending data to scientists back on Earth. These scientists continue to study it and trying to learn more about the origins of this solar system and what lies on its outer edges. Pluto still has a story to tell. There are questions that need answers, and the answers will come through science. New information is just waiting to be discovered. And so that I know you listened to this story, there is my lazy dog, Jasper, who I told you likes to sleep all day. Jasper, there he is. So send me an email saying you listened to the whole story and you got to see Jasper. Talk to you guys later.